Okay guys, now let's go with this topic, interrupt control system. Alright, basically we have done this in the lab session. What is interrupt? Okay, I suppose that you already have some knowledge about how interrupt happens, and basically this topic in the notes in the class session will enhance your knowledge about the interrupt. At the end of the class, you should be able to understand different type of interrupt and its operation. You should be able to differentiate between polling versus interrupt. And then understand the interrupt related special function registers. What it means here is that the interrupt, the registers that you need to set in order to use the interrupt. Okay, there are two methods to provide interaction between microcontroller and the external system. The first one is polling. This is the normal way of doing it, and then the interrupt, which is the better way of doing, getting the input and so on. All right. So three potential sources of interrupt. We have hardware, processor interrupt, and the software interrupt. So whenever the interrupt happens, processor halts the thread execution, which means it stops for a while and do whatever the interrupt is asking to do. Okay, polling. What is polling? Is the process where the processor execute line by line at one time, and then you have to wait for your turn when the input is required. So when the main drawback is writing a program that uses this method is a waste of time. Okay, waste of time. Kenapa dia tanya why it says that it's a waste of time? Because CPU needs to wait and review whether the new information has arrived. For example, if we look into this example program code, okay, for example, this is a tally counter. This is the main program, and this is the function, whereby we call the function inside the main program. So this is define, and then initialize all the values. In the main program, initialize set trace as the input or output, and then port B as the output. And then here where the program repeats or loops forever. Okay, while true, first what it does is check count button. So when this happens, it will go to the function count button, which is this one. Okay, process this, check if the button is being pushed. Okay, like what you did in the interrupt, you might probably doing this. If not input macam tu saja. Okay, so what is this means? Means equals to 0, meaning when the button is pressed, it triggers. 0 is on. Because why? Because we are using active low switch. For example, if you look at this, like I said in the lab session, when you have switch like this, okay, this is 10K. This one goes to your port. Let's say button here, count button A0. Okay, A0. So when you press the switch, A0 becomes connected to ground, which is active, which is 0. So that's why you have to check if the input button is 0. If you are using different type of switch, for example, active high, like this, if you press the button, then A0 becomes high. So then only you can use if input button equals to 1. Okay, right. Let me erase this part. Right, so what happens here is first do this, and then second do this, and do this, and then repeat forever. Okay. uh, in actual, when you call the function here, it will go here, right? You may say that, okay, this looks like interrupt, but actually no, because this is done every time. Meaning bila dia ulang balik, when it's recycle back again, look back to the origin, it will process this somehow or other. If whether the input has some is being triggered or not, it will still execute. It will still check the button. Okay, like interrupt, it doesn't need to check. It will not even process if there is no interrupt is happening. When the interrupt is not happening, it will never check. Okay. So this is the difference. Polling, you do you check everything one by one in the process. Okay, another example of polling method in this program code. Okay, set trace output D, and then while true. While true is where the program repeats. So here we have delay for second, output toggle pin D7, and then input pin B0 equal to 0, meaning if pin B0 is triggered or pushed, and then output toggle pin D0. So what happens here? It executes. How do I show this? Let me put numbers. 1, and then execute number 2, and then execute number 3, okay, and then number 4, and then number 5, it will go back here, and then number 6, number 7, number 8, and then come back, number 9, number 10, 11, and 12. So this is how the thing goes. I mean, it will repeat itself like forever. And every time it will check the input. Okay, it's like you're waiting for a bus. You are sitting in a building, and then your bus stop is just right in front of the building. So you keep on checking whether there is a bus or not. So you come out of the building and check. Oh, the bus is not there yet. Okay, let's go back to the building. Let's go back to the library, for example. Read your books, work with your phone or whatever. And then after some time, you go out again and check. Oh, is the bus is here or not? No. So you come back in. So that is what we call polling, meaning you go and check if the bus is there or not. Interrupt means when the bus coming, it honks, or you have some sort of notification system. Oh, the bus is arrived. So you don't have to wait at the bus stop. You just wait for the signals that the bus is coming. So this is where the interrupt. So if you're reading a book, then the signal, there is a notification saying that the bus is here. So you stop reading and go to the bus. Okay, this is how the polling and versus interrupt happens in real life. Right. So this is how the polling goes. So what's wrong with polling? For example, like at this point of time, so this consumes some time on the processor time, okay, and then it only checks the switch at this point, whereas the rest of the time it will do other things. Like this, for example, is a short program. Maybe you don't see that much difference. If you have a long program, a very long program, let's say for example two or three pages, and then only one time you will come back to check the switch. So you can imagine, there will be time that when someone press the switch, the program, the microprocessor or the program didn't notice that, didn't capture that, because it was executing some other things. Okay. To put it in an analogy, like you're waiting for the bus. When you check outside, there is no bus, so you continue reading in your library, for example. When the bus arrived, you didn't notice because you're reading, and then after, let's say, 10 minutes, you go out and check again, the bus has already went through, meaning you missed the bus. Because why? You're doing polling method. You only checks, let's say, every 10 minutes. Okay? So after, within the 3 minutes after you have checked, the bus comes, you miss the bus. But interrupt, you don't have to go and check. Okay? You wait until you hear the sounds of the horn, the bus honking when it arrives. Then you know the bus is arrived. You stop reading, you stop doing whatever the work you do, and go to the bus. Okay, so this is how it goes. Okay, the definition of interrupts: event that disrupts the normal execution of a program and causes the execution of special instructions. Okay, when an interrupt event happens, code execution stops where it was. Okay, and then an interrupt service routine is called to handle the interrupt. After it completes, it returns back to where the code was running before. Okay, interrupts asking the processor to stop to perform the current program and to make time to execute special code. Okay, this special code is saved in the subroutine, interrupt subroutine, or functions. Okay, each interrupt changes the program flow, interrupts it, and after executing an interrupt subprogram ataupun interrupt routine, it will return to the point in the main program. Okay, for example, this is a current instruction, interrupt active. Okay, set the the process, clear, interrupt, stack program counter, go to the address, interrupt routine, finish, return back. Okay, so interrupt vector, in flash memory, we have an interrupt vector. Interrupt vector indicates, okay, this is where your okay, meaning when you write program code for interrupt, it will save in an address. Okay, and then the address is being recorded or saved in the interrupt vector. So this is how in the flash memory, you have a list of program codes is saved in the memory. So the program executes line by line. So when interrupt happens, okay, when interrupt happens, the address of the program code will be saved onto the stack. Okay, we will be saved onto the stack, and then when the interrupt program or routines finish, the stack will return back. Okay, this is a bit messy, so let me show from the slide here. So this is the process where the interrupt happens. So the address of the current program code will be saved onto the stack, and then it will jump to interrupt routine. So this is the interrupt routine. So it will process whatever the program code that you put in your interrupt routine. After you finish, okay, there is one line here, return from interrupt. Okay, so the the address program counter saved at the stack will return back, which means it will continue where the program last executes. Okay, this is another way of showing it. So this is the program execution flow line by line, and then suddenly there is interrupt. So what happens is when the interrupt, external interrupt, for example, in this case, push button, external interrupt, and then it stops the current program. It will go to the sub program where the interrupt is interrupt code is listed. So it will process that, and then after that it will return from interrupt, come back to where the program stops. So program will continue from there. Okay. So interrupt sources, there are several sources of interrupt. For example, external hardware, which you use in the lab, which is PB0, okay, port push button connected to the port B0, for example, okay. And then microprocessor can set itself an interrupt, and then a multi-processor can interrupt each other. Okay, two types of interrupt: software interrupt and hardware interrupt. So like the one that you have for the push button is the hardware interrupt. Okay, software interrupt come from program that runs by the processor and requests to stop running the program. Okay, go to make interrupt and then return to continue execute program. For example, procedure, when there is a procedure call, processor stop execution of the program, jump to, okay, and so on and so forth. This is how you set up a software interrupt. But what you do in your lab session is the hardware interrupt. Okay, sent to the microcontroller by external hardware, which is the pin. Okay. Some interrupt can be blocked or maskable by interrupt enable bit. So when interrupt is blocked, microcontroller cannot see the request for its interrupt. Therefore, it won't be able to execute it. So the block interrupt will only be executed until the block is removed. So this is where the setting is. I don't want to confuse you with too many things. So maskable, non-maskable is the setup that we use in the special function register. All it says that we have to set the special function register for the interrupt to happen. Okay, basically the microcontroller, in this case, for example, PIC 168F877A can have up to 15 interrupt sources. Some of them includes internal peripheral sources, which is a timer, which you did in your lab for, A to D converter, okay, can also be a source of interrupt. Serial I/O communication, for example, USART, SSP, SPI, or S2C. These are the communications. And then we can have external sources, for example, RB0, interrupt 0, used to connect external interrupt source, keypad or switches. And then we can have a port B interrupt, RBI, port B interrupt change in logic levels pin RB4 until RB7. Okay, why do we need interrupt? It's for time critical application, performing routine tasks to service peripheral devices quickly. Okay. All right, this is all the logic gates coming from datasheet, showing how the interrupt or process of interrupt setting. Okay, I'm not going to go into detail of this. Right, let's look at the control register for the interrupt. Is called INTCon, which is interrupt control register. You have to set this for the interrupt to happen. Okay, and can be accessed regardless of the memory bank selected. The role is to allow or disallow interrupts. In case they are not allowed, the register single interrupt request through its own bits. Okay. All right, this is the bit what we do in your program code. Okay, here we have global interrupt enable bit. And then if you were to use peripheral interrupt, you use peripheral interrupt enable bit. And then we have learned this last topic, timer 0 interrupt enable. And then we have INTE, which is in external interrupt enable bit. For example, if you want to use RB0, you have to enable it here. So let's say you want to use RB0, you have to set 1 here, and then you have to set global interrupt 1. Okay. And then RBIE, which is port B change. Okay. Interrupt enable bit. If you want to use the rest of the port B, 1 is enabled, 0 is not, it is disabled. So let's say you want to disable it, and then we are not using timer yet. Okay, peripheral is not using it yet. And then we're going to use timer 0. No, we're not using timer 0 interrupt. And then let's say we want to use port B0 interrupt flag. So INTF is port B0 interrupt, external interrupt flag bit. So you have to set is as 1. Okay, 1 means B0 external interrupt occurred. Okay, must be cleared in the software. Okay, you have to clear the flag, meaning for the next interrupt to happen. So before the interrupt happens, this one set to 0, because when the interrupt happens, it will automatically set to 1. Okay, so in the software you have to set it to 0. RBIF port change interrupt flag bit. Okay. At least one of RB7, RB4 pin change state, that means reading the rest of the port B4 until B7. Alright, so now let's, in case because we want to use port B0 interrupt, so these are the setting that we're going to use. So INTCon, you have to send 0 times berapa ni? 90 in hexadecimal. Okay, this is an example. If you were to use port B0 interrupt, so your interrupt INTCon register, let me put it in there, because register is capital. Right. Let's say if you were to use for timer, so how the setting should be, timer interrupt. So INTCon should be like what? Let's say, let me erase this part first. So if you want to use timer 0 interrupt, so you have to enable global interrupt, then you set timer 0 interrupt enable, and then timer 0 interrupt flag. So once you set all this, you will get what? 0 times, so the rest is 0. So what you got here is 0 times A4. Okay, so this is A, this is 4. Okay, this is how for you to set the the INTCon interrupt control register. Right, next. Okay, peripheral interrupts. If you were to use external interrupt peripherals, internal peripherals, for example, EEPROM, serial communication, timer ADC, and so on. Peripheral interrupts are configured by using PIE1 registers. These are all peripherals. What it means by peripherals, meaning, you remember you have a microcontroller, and then you have a RAM, ROM, memory, and then you have ADC, and then you have COM. Okay, these are all peripherals. Okay, so if you were to enable EEPROM, you have to enable, you can use this, enable ADC interrupt communication in ports interrupt. So you can use this PIE1 register. In some microcontrollers, there is also PIE2. The interrupt control register has one bit, which is called PIE. Okay, PIE enable. Where is it? Yeah, here. Peripheral interrupt enable bit. If you were to use that, you have to set to 1. Okay, the rest you can read on your own. Okay, peripheral interrupts register PIE. Here we have PSPIE, parallel slave port read write interrupt enable bit, and then you have ADIA, A to D converter interrupt enable bit. Okay, so you have just done lab 5, so which is the analog digital converter. So when the analog reading completes, it will produce interrupt like this. Okay, so it will trigger the interrupt process. The processor will process it, and then our CIE, which is a user receive interrupt enable bit. Okay, and then the rest is what? TXIE, user transmit interrupt enable bit. We are not really going into detail in any of this part. What we usually cover is whatever that is being taught in your lab session and also in the class. But the class, of course, will cover broader details. But the lab goes into much more focus points that you need to know. So the rest, like synchronous serial port, CCP, interrupt enable bit, capture compare. CCP is capture compare, interrupt enable. So actually, there's a lot of functions that you may use or you may not use in the microcontroller. But we focus on because we got 6 labs. Each of the labs will be covering some essential points, essential knowledge that you need to know in the microcontroller topic. Right, so probably I could skip. All right, this timer 2. Okay, you have learned about timer previously. Timer 1 interrupt. Okay, and then PIR. We have PS, PIF, ADIF. What are those? Parallel slave, almost similar to the previous one, which is a PIE. User transmit, receive, serial port synchronize, capture compare, flag. Okay, I'm not going into detail for that. So these are all, for example, when you set this global interrupt enable, you set global interrupt enable 1, and then you set timer 0 interrupt enable. Okay, this switch on, this switch on, this switch on, and then you will get the setup, the certain interrupt. So you can have different type of setting. For example, if you were to use let's say port B interrupt, so this one must be on, RBIE must be on, and port B interrupt flag must be on, and then it will enable the interrupt. So the process will, this is analogy. Okay, this is analogy how you need to set. These are the setting that you need to do, the bit that you need to set in the control in a register, special function registers. For example, INT-con, interrupt control register. All right, so this is an example. You might look this some sort of familiar program code that you have done this in the lab. So if you see here, there is a program code here. You have all the initialization, and then suddenly you have this interrupt function. We call this interrupt function. So the processor doesn't process this like this. Okay, it will do the initialize and then go to the main program. Okay, interrupt function here is not being executed yet. it's there in the EEPROM, but it's not being executed yet until it is triggered. Until the interrupt is triggered, then only we do that. Right, in the void main, first thing you clear interrupt, and then enable interrupt global. Okay, so global ni which is global interrupt enable lah. Dan port B interrupt tadi apa tadi? Ni RBIE, port B interrupt enable. Okay, and then this one clear interrupt flag. What we call it just now, RBIF. And then while true means it will execute this program loop forever, walaupun tak ada apa-apa. Even though if there's nothing here, but the processor still executes. It will go round and round here like forever. So when interrupt happens, then only it will stop. Okay, it will stop. You will go to the interrupt routine. Okay, it will process this line by line, 1, 2, 3, and then finish this, and then only will come back. Okay, that is what we call return from interrupt. You see this while true is doing nothing, there's no program code, you might confuse a bit. But if you have, let's say, so many lines of programs, okay, on LED or whatever, okay, so when interrupt happens, it will stop there, go serve the interrupt, and coming back where it stopped last. Okay, sambung balik. Okay, interrupt example, port B interrupt detected changes on RB7, RB4, for example, for low to high or high to low, and then what happens? So for RB0 interrupt, you need to global interrupt enable, interrupt flag clear. Right, and then what else? Interrupt H, you need to set. So here you have this is not interrupt, this is just to set pin C0 low, and then external interrupt H high to low. Okay, here is where you use the interrupt H, kat sini. What is interrupt H? H ni maksudnya apa? H means at the end of something. Okay, so it detects interrupt H, meaning it detects from the changes from low to high or from high to low. And then what happens? Clear interrupt, enable interrupt, which is the this one. Clear interrupt is which one is that? Here. Okay, clear interrupt flags. Okay, sorry, this is a bit misleading. This one is here, enable interrupt, and then enable global interrupt, which is this one. Okay, and then the rest of the setting, and then let's say here, this is where this is an example where you have a program code inside while true, so it will do endless loop. It will repeat here like forever. So when interrupt happens, when interrupt triggers, so it will stop the execution of the codes somewhere here, and then goes to serve the interrupt. And then it runs here, and then runs here, and then it's finished, it will come back. Okay, return from interrupt, continue where it stops. Dekat mana last dia execute, and then it come back and continue. Okay, this is another example interrupt. Yes, interrupt H high to low, and then you set int con. What is this? What does this mean? Do you find this familiar? Let's go back. let's go back where you found this interrupt control register. Here. See this? Here, like I explained previously. So what it means by that? 90 means 1001 0000. So what you are doing here is set the port B interrupt, port B0. Let's go back to the where we stopped last. Okay, so you set PB0 as the interrupt source. Okay, what's next? And then timer interrupt. Okay, we have learned about the timer interrupt previously. Okay, the best thing about timer is that they work in the background. Delay loops such as delay millisecond or delay microsecond will pause your program. You have to wait for them to complete. Contoh macam ni lah, like this. You have to wait. The processor will execute this for 4 seconds. This is actually a function. There's a function delay. It will do whatever the counting or whatever to create delay. It counts the time until 4 seconds, and then it will come back and do the output toggle. So it's actually executes line by line. So there was line 1, line 2, line 3 in the function, line 4, line 5, and so on. Finish it, and then it will come back to the main program. So this is a function delay. But what happens is it consumes the processor time. If you're using timer as an interrupt, then it doesn't consume your processor time. It runs in parallel. When the timer finish or timer overflow, it will produce interrupt. Then what we do, stops microprocessor processes. Then what we do, execute, not timer, execute interrupt function. And then what happens? Finish, continue the program. Right? So again, let's review interrupt versus polling. Polling, it asks the device if it has any data. Okay, meaning it will execute one line by line and then checks if port B0 equals to 0. If not, then proceed. But interrupts, you don't have to check if port B equals 0. It will execute interrupt will execute line as usual. Let's say port B happens to have interrupt, then it will stop, serve the interrupt routine, finish, and then only come back. Okay, so device tells CPU that it's ready with that or for data or needs to service by interrupting the CPU. Okay, so by now you should be able to explain the difference between the polling and interrupt. Polling means you do that one by one. You check the port B push button, is it being pushed or not? And then if not, then you proceed with the rest of the program. Okay, so advantage and disadvantage. You compare interrupt versus polling. Interrupts are more complicated, additional setup required. Polling is simple, very little setup is required. Interrupt signal will be processed faster, but polling will slower to process input. Macam like you're waiting for the bus, you have to check every 1 minute or every 10 minutes. But interrupt, you don't have to wait. When it happens, it will stop whatever you're doing and then you will serve the interrupt. So chances are polling, you may miss the signal. Okay, when someone press the button, you may miss it because you are processing another thing. But interrupt, you won't miss it. Okay, when someone push the button, the processor will stop and interrupt happens. And then interrupt, difficult to debug due asynchronous behavior, and polling is straightforward debugging process. So those are textbook differences between interrupt versus polling. But you should be able to explain in your own words if you really understand the meaning or the definition of interrupt and polling.